Hello and welcome. This video will continue our discussion on problems on types of functions. Here we have f of x is equal to 6 power x plus 6 power minus x. Oh, so it's not 6 power minus x, it is 6 power mod x. What I do is I'll take this as f1 of x and I'll take this as f2 of x and plot it separately and then add. So first I'll take f1 of x. I'll take f1 of x here. If I put x is equal to 0 for 6 power of x, this is 6 power x. When you put x is equal to 0, so at x is equal to 0, you'll get 6 power 0, which is 1. So at 0, it is 1. And if you put x is equal to 1, it is 6 power 1, which is 6. So at 1, it is 6, somewhere here. And as I increase x in the positive x-axis, the value of 6 power, the value of f1 of x will increase. Like if I put a maximum value or a very big value, let's say if I put x is equal to infinity, I'll get 6 power infinity, which is infinity. So it increases to infinity in this direction. So when I put x is equal to minus 1, I'll get 6 power minus 1, which is 1 by 6. So it decreases. If I put minus 2, it becomes 6 power minus 2, which is 1 by 36, which is still less than this. So if I put a very minute value, let's put x is equal to minus infinity, we'll get 6 power minus infinity, which is 1 by 6 power infinity, which is 1 by infinity, that is 0. So it goes to 0. So this is my 6 power x. So all a power x functions, if a function f of x is equal to a power x, it looks like this if a is greater than 1. Here a is greater than, which is 6. Now let us plot f2 of x. This is my f1 of x. I'll plot x2 of x, f2 of x, sorry, f2 of x. We have 6 power mod x. If you put x is equal to 0, you'll get 6 power 0, which is 1. So it is 1 here. If I put x is equal to 1, it is 6 power mod 1, which is 6 power 1, which is 6. It is 6. So in the positive side, it looks very similar to f1 of x, which is like this. Let me write it properly. It looks like a curve like this. It goes to infinity. So now at the negative x-axis, it takes a really interesting form. If you put x is equal to minus 1, you'll get 6 power mod of minus 1, which is 6 power 1, which is 6. So at minus 1, it goes to 6. So, and if I put x is equal to minus 2, this will be 6 power mod minus 2, which is 6 square, which is 36. So it in the negative x-axis also, it goes to positive infinity like this. So this is my f2 of x. Now if I add these two, if I add these two, I'll get at the right side, we have from 1, right side. If I add these two, you should get more positive values like this, because both are positive. When you add two positive values, you get a bigger positive value. And here also in the negative axis, all the values are positive. So this is also positive, this is also positive. When you get positive values like this. So this is how 6 power x plus 6 power mod x looks. Now with this plot, it's very easy to find very easy to find which type of function is this. If I want to check 1 I'll take an horizontal line and move it through the function. See, at one point it touches the function at 2 points. So it is not 1 it's not 1 and the range, the y value it covers, the function covers, is this is 1 to infinity. So the range of this function is 1 to infinity. So it does not cover values from minus infinity to 1. The function does not cover these values, hence it is not onto as well. It is not onto as well. So function is the function is many many to one and into. It's not onto, so it is into, and it's not one, so it is many to one. So option D is correct. Let's solve one more problem. So here we have a function from natural numbers to natural numbers. So x can take from x values are from 1, 2, 3, 4, 5, and so on, like this. f of x f of x f of x is equal to, I can write this is x when x is even, when x is even when x is even, minus 1 power x is minus 1 power x is positive 1, because minus 1 to the power of even number is plus 1. When x is odd, minus 1 power x is actually negative 1. So what I can write here is, x minus 1 when x is even, because minus 1 power x will be positive 1, x minus of minus 1, or I can write x plus 1 when x is odd. So now we'll write the functions. Let's say we have the inputs from the natural numbers 1, 2, 3, 4, 5, and so on. Now it is mapped to, so if x is even, if x is odd 1, if x is odd, we have to take this one, 1 plus 1 is 2. When x is even, so here when x is even, it is x minus 1, so 2 minus 1 is 1. Again this becomes 4, 3 plus 1, this becomes 3. So you can see every element is mapped to only one element, one is mapped to 2 only, and every odd number is mapped to only one element, every even number is also mapped to only one element. And we can also see the range or the domain, uh, the, the range here is actually the same natural number but in a different order. So it covers all the natural numbers. If you keep on continuing this, it covers all the natural numbers. So this is both 1 1 and odd. This is both 1 1 and odd 2, and the option is A. Thanks for watching.